All right, so ladies and gentlemen, we're going to get started on chapter 7.1. We're going to look at rational functions. Again, we're looking at fractions. One of the things that you guys should know is we can never, ever, ever divide by 0. Okay, if I take my fancy calculator, I got my TI-84, okay, and if I take Mr. Gotch's salary, $1 million or $10 million, whatever that is, and I divide by 0, I get an error message that says you can't divide by 0. I can't take a candy bar and divide it into 0 groups. I just can't do it, okay? And if you ask Siri, you know, what 0 divided by 0 is, it gives you some silly answers. Something about Cookie Monster or something like that, okay? You can't take any number and divide by 0. Just impossible. All right, so when we're looking at rational functions, one of the first things that we got to be able to do is find the domain. And guys, domain is basically what x's or x values work. So we're trying to come up with what x values work for our expression. More importantly, we're trying to figure out basically what makes the denominator 0, and we're going to exclude that guy. So you can do anything except for what makes the bottom 0. So that's what we need to do today, is we need to find the number or numbers that make the denominator 0. All right, so we got to find what number or numbers make our denominator 0. Okay, so when I think of domain, I want you to think denominator. Okay, so what I'm going to do is I'm going to highlight my denominator of this first expression. I've got f of x equals 3 over x plus 5. I'm going to highlight that denominator, and I know x plus 5 cannot be 0. So set that guy, whatever the denominator is, set it equals 0, and I'm going to find out what makes it 0. So I go ahead and subtract the 5 over, and I know x cannot be negative 5. It can be anything I want. I can plug in any number. If I plug in 1, I get 3 over 1 plus 5 is 6. I get 3 over 6. I get a number back. But if I plug in negative 5, negative 5 plus 5 is 0, and 3 divided by 0 is undefined. Okay, so we're trying to find out what makes this thing undefined, and we exclude it, which is why I have the equal with the slash on it. Okay. Now here's some fancy notation that you could see in my math lab. Okay, so we're going to see domain. We're going to use the letter D for domain. And then you might see some fancy brackets. So domain is the set, and then you're going to see like something like this where it's x bar. That just means domain is the set of all real numbers except negative 5. Okay. Now you're going to see the pink thing already written in. What you need to be able to do is just type in this negative 5 here. Okay. All right, so let's try this guy again. I'm going to go down to C here. I've got h of x equals negative 5 over x times x plus 7. Okay. And they're asking us to come up with the domain. We're trying to find the number or numbers that make my denominator 0, and I'm going to exclude them. Okay. So this goes back to what we learned in chapter 6.6, what we just finished. X, set that x equal to 0. And set this x plus 7 can't be 0. So again, this whole thing cannot be 0. Set both of them equal to 0, just like we did in the last section. Now, a lot of you guys were able to solve this on your own. Subtract that 7 over, and we get x cannot be 0 or -7. There's two values that I cannot have for my x's, my domain. So domain is the set of all real numbers except 0, -7. Again, the big thing is you're just going to be punching these numbers in for my math lab. You won't have to be typing in this fancy notation, but I can write underneath what this all says. Domain equals is. This is set notation, so the set x bar, this little x with a little bar, means of the set of all real numbers. And then except 0 and -7. So that's what that notation is. Domain is a set of all real numbers except for 0 and -7. Okay. Questions so far, y'all? Okay, so domain, denominator. I don't see any questions so far. Give me a thumb. Where are we at with us? Sideways, upside down, thumbs up. Not seeing many thumbs. I hope we're writing this stuff down. All right, so let's try a couple more. Okay. I want to include this one for part B. It says I've got f of x equals 2x over 3. Again, my denominator cannot be 0. Well, there's no variable to solve here. It's just 3. 3 cannot be 0. That doesn't make sense. Okay? So if there's no variable to solve, then there's no exclusion. Okay? So my domain is all real numbers. So again, if there's no variable, no exclusions. If there's no variables, there's no exclusions. That means I can have any number. I can plug in any number into this function, I'll get a number back. Okay? When I look at D, I've got g of x equals x plus 5 over x squared minus 8x. Again, look at your denominator. X squared minus 8x cannot be 0. So we go back to what we learned in 6.6. Okay? We have a quadratic and we want to solve this guy for 0. Okay? So we got to go back and factor. How do we factor x squared minus 8x? What do we got to do? You guys can use your chat, use your microphone. X squared minus 8x. What's the first rule of factoring? What can we take out? What do you think, Riley, Eddie, Kai? Take out an x, Hunter says. That a boy. So take out that x, and that leaves me with x minus 8. Okay? From there, I would set each one of these equal to 0, but we know the first one is 0, and then we knew that if we have x minus 8, the answer is going to be the opposite sign. At least we should. So we get the exclusions of 0 and 8. Again, if you want your fancy brackets, domain is a set of all real numbers except 0 and 8. Okay, 0 for this guy and 8. 8 minus 8 is 0, and 0 divided by anything is undefined. Or anything divided by 0, I should say, is undefined. All right, I got one more of these domain ones. Okay, so last one, E for domain, and we got some simplifying we can do. When I look at this denominator, now we got a trinomial. And I know if I'm looking for domain, my denominator can't be 0. So I go back and factor, just like we did in the last section. So I've got x squared minus 2x minus 15. We want to solve that, guys. So I factor. Factors of x squared are x and x, and now I need factors of negative 15 that add up to negative 2. So that's when I ask you guys, what are factors of negative 15 that add up to negative 2? What are they? Is it 1 and 15? 15 and 1? Is it 3 and 5, 5 and 3? And which one's positive, which one's negative? So factors of a negative 15, one has to be a plus, one has to be a minus. What two numbers multiplied together gives you negative 15, added together gives you negative 2x? Jimmy, what do you think? Greg, what do you think? Jasmine? Jose? Isabel? Hunter? Ethan? Michael? What do you guys think? What are factors of negative 15 that add up to negative 2? Mariana, you got them? Juliana?
I put negative 5 plus 3.
Awesome. That's perfect. Nice job. So multiply together is negative 15. Add together, negative 5 plus 3 is negative 2. Now my solutions, again, is what makes these guys 0. So if you need to, take x minus 5 and set equals 0, you'd add the 5 over. And same thing with that plus 3, you would subtract it over. So x cannot be opposite sign, negative 3 and positive 5. Okay, so I get a domain as all reals except negative 3 and 5. It can be anything. It could be 4, it could be 5, negative. It could be negative 7, it could be 10, it could be 0. But if it's negative 3 or 5, when I plug those in here or here, it makes it undefined. And that's our goals. We're trying to figure that out. And that's it, ladies and gentlemen. So all you're going to be doing in my math lab is, again, looking to find what makes the bottom 0, and then what you're typing in are just these two numbers. Okay, everything else should be typed in for you. So goal number 1, domain. I hope that's easy. Domain, denominator, what makes my denominator 0? Goal number 2 says we're going to simplify rational expressions. Okay, so when we take a look here, we're going to get started, and we're not going to do every single one of these. We're going to do, I don't know, 5 or 6 of them. The thing that we need to know is, first off, what a monomial is and what a binomial is. Okay, monomial means there's one term, binomial means there's 2 terms. And what we need to know is that a monomial and a monomial can be reduced. Okay, so monomials can cross out monomials. And then we need to know that binomials cross out binomials. So that's 2 concepts that we have to understand. We also need to know that you can't just take pieces away from a binomial. So again, you have to take the whole thing or nothing at all. So when I take a look at example 2a here, I have 3x to the 7th divided by 12x to the 5th. This is a monomial, this is a monomial. This is something that's okay to reduce. Okay, these are both monomials. So I take a look. This is something we've actually done earlier in chapter 5. We had 3/12. If I look and I cover up the x's, okay, 3/12 reduces by 3. So 3 and 12 reduced by 3, that leaves me with 1/4. And then on top, the x to the 7th and x to the 5th reduce. So if you need to, you could write out all these x's. And on the bottom, all these x's. 1, 2, 3, 4, 5. And these are all reduced in these guys. So we reduce, that leaves me with xx or x squared. So final answer I'd probably write is just x squared over 4. So again, this is an example of a monomial reducing another monomial. I'm going to do C first before we do B. This is what I'm talking about with a binomial and a binomial. Okay, on top of C, example 2C, I've got x plus 3, and the bottom I've got 3 plus x. Well, if these are exactly the same, we could cross these out. Okay, so I'm going to rewrite the bottom one. 3 plus x is the same thing as x plus 3. And this binomial are exactly the same. And if they're exactly the same, then I can cross out this quantity. Okay, think of them as like a team. You either cross out the whole x plus 3 or you don't cross anything out. All right, so x plus 3 divided by x plus 3 reduces down to 1. So far, so good. Again, this is something you guys did in Algebra 1. This is just going back over this stuff. So now I take a look at B. So if you're writing this down, I've got 5x to the 3rd minus 10x squared, and that's all over 25x to the 5th. Okay, on top, we call this a binomial. There's 2 terms. On the bottom, I've got a monomial. And this is where I can't just go take pieces away from everything. Okay, that doesn't work like that. Only monomials reduce monomials. Okay, you can't take and split up this binomial unless you factor. Okay, so before you start trying to cross things off, ask yourself, can I factor? So write this, can I factor? Question mark. That's what you should be asking yourself. Well, I take a look on top. Okay, I'll do this part in blue here. I've got 5x cubed minus 10x squared. What do they have in common? What is the GCF here? What can I factor? What do you guys say? And again, the faster you guys answer, the faster we move on. Get you guys out here early. 5x cubed minus 10x squared. What do they have in common? Destiny, Claudia, what do you guys see? What's the GCF there? What are they both divisible by? 5, Greg says. More than just 5. So you got the coefficient right now. What about the x's? X to the 3rd, x squared. A little bit more than 5x. 5x. This has got a 3rd. This has got a squared, so 5x squared. Okay. So I'm going to go ahead and factor that. So very good, guys. If I divide this guy by 5x squared, that leaves me with just an x. And then this is a negative. Negative 10 divided by 5 is negative 2. And then the x squared is on the outside. Okay. And now on the bottom, I've got a 25x to the 5th. Okay. Well, now this is a monomial. These guys are monomials. These guys can be reduced. So R for you pirates out there. We can reduce this thing. Okay. So the 5 and the 25 reduce. The x squared and x to the fifth reduce. That leaves me with x cubed on the bottom for the x's. So the whole top completely reduces except for the x minus 2. And on the bottom, I'm left with 5x to the third. On top, I have a binomial. On the bottom, this is a monomial. They don't work together. You either take the whole x minus 2 or you don't take anything. Okay? You can't just take pieces away. You can't do that. Okay? Take the whole thing or nothing at all. You can't just take a little x out of there. Okay, any questions with that? All right. Give me a thumb, guys. Give me something. Because a lot of you guys aren't saying anything. Give me a thumb. Did you guys know off on the side you guys can do thumbs up and thumbs down? Did you guys see that off on the side there? You can go over to more and do thumbs up, thumbs down if you're off camera right now. Or you can visually give me a thumb. All right, thumbs up. Here we go. All right, so we take a look at the next one. Again, I can't just reduce these 3's and these x's. It doesn't work like that. Okay, these are binomials. I either reduce the whole thing or nothing at all. The first thing I notice on this one is I don't like how this one's written. I'm going to rewrite that as negative x plus 3. I always like seeing my x's first. Okay, and I'll do the bottom here in pink, so that's divided by x minus 3. Okay. This quantity here, okay, is not quite like the quantity on the bottom. They're very similar, but they're just off a little bit. And they're off by the symbols, right? This is a negative, that's a positive x, that's a positive 3, that's a negative. Well, this is what we call the additive inverse on top. What we can do is we can take out a negative. So if I take out a negative or negative 1, what leaves me with is a positive x and a negative 3 there. And on the bottom just stays the same as x minus 3. Well, now again, binomials reduce binomials. These x minus 3's, karate chop. If you're watching Cobra Kai, a little karate chop on that. And all I'm left with is that negative 1. Is anybody watching Cobra Kai out there on Netflix? Nobody? Oh, man. Just me, I guess. All right, so final answer on D. A little karate chop. These x minus 3's cross out and leaves me with negative 1. So when I take a look at E, I've got 7 minus x. Again, don't like how that's written. I always rewrite it. And if there's ever a negative in front of that x, I'm going to factor that out. So I'm going to take out a negative 1, and that's going to leave me with x minus 7. Well, now I've got this guy. I've got 3x minus 21. And what are those guys reducible by? What can I factor out there? Show me fingers. Type it in the chat. What can I factor out there? 3x minus 21, y'all. Hunter says a 3, you betcha. So I'm going to put that here. And if I divide by 3, that leaves me with that x minus 7. Again, monomials reduce monomials, binomials reduce binomials, karate chop these binomials. And that leaves me with negative 1/3. Guys, we got 2 more left. 2 more, that's it. All right, so I take a look at the next one. F. I've got x squared minus 4x, and on the bottom I've got x squared minus x minus 12. All right, let's take a look at the top. Factor. The people that are going to get this completely wrong, they're just going to karate chop the x squareds. You can't do that. Okay, you can't just take pieces away from a binomial and a trinomial. You've got to factor. Okay, so the people that are going to get this thing wrong, man, they're just going to, oh, x squareds, cross them off. Oh, no, doesn't work like that. Okay, so I've got x squared minus 4x factor. What can you factor out here? What can you take out? X squared minus 4x. What do they have in common? Hunter says an x. That leaves me with x minus 4. Perfect. And now we got to factor this trinomial on the bottom. So I got x squared minus x minus 12. They want me to factor. I know it's going to be 2 sets of parentheses. And x and x. Factors of negative 12 that add up to negative 1x. So I got to check my outers and inners, my smile and nose of SpongeBob. If you're struggling with factors, look at what's already been factored up top. I bet, not always, but I bet this binomial is going to cancel. So I'm going to try negative 4, and then a factor of negative 4 of negative 12 would be positive 3. And sure enough, that's 3x and negative 4x, that's negative 1x. Okay, so if you're struggling with your factors, look at what's up in the numerator already. Okay, so this x minus 4 karate chops. And now I've got a monomial of x and a binomial of x plus 3. Can I reduce the x's, guys? Yes or no? Should I cross these out? Can I take a monomial and reduce the binomial? You better not. Okay, you can't do that. Wish you could, but you can't. Okay, and mathematically, here's the idea on why you can't do that. Okay, so let's say we have 5 plus 3, and on the bottom we got 5 plus 4. Well, we agree 5 plus 3 is 8, and we agree 5 plus 4 is 9, right? So simplifying that, that's 8/9. Well, on top, this is a binomial and this is a binomial. You either reduce the whole thing or you don't reduce anything. So the top doesn't reduce. But I'm going to have some people say, oh, this is an x and that's an x, so I cross them out and it gives me 3/4. Well, mathematically, 8/9 and 3/4 are not the same. So you can't just take pieces away from binomials. It doesn't work like that. You either reduce the whole thing or you don't reduce anything. Okay? So hopefully that helps, gives you a visual on why that works. All right, let's finish up. Last one for today, ladies and gentlemen. I got G. I've got 3x squared minus 48. And on the bottom, I've got 3x plus 12. So I'm going to factor this top. I'm going to take off a 3, I think. It's like that's divisible by 3. Negative 48 divided by 3 is negative 16. Well, that can be factored further. Okay? And I'm running out of room, so I'm going to write it over here. That is a difference of squares. Factors of x squared are x and x, and factors of negative 16 that add up to 0. One's a plus, one's a minus, 4. And now 3x plus 12 factors. I can take out that 3, and that leaves me with x plus 4. These binomials karate chop. Do you guys see anything else that can be reduced? What else can be karate chopped, reduced here? Hunter says the 3's again. Yep, we got monomials. Monomials reduce monomials. So after the dust settles, I look to see what's left. The only thing I got left is this x minus 4. That's on top, so there's no more fraction. There's nothing left on the bottom, so final answer is just x minus 4. Ladies and gentlemen, that is pretty much all we have for chapter 7.